Good morning, students. Today is the first class for PU first students regarding the chemistry chapter. Okay, I'm your chemistry teacher. My name is Akshita. So we are going to discuss about first. What is the branches of chemistry that you are going to have in the first year? How many branches are there? So in 10th you already only studied like chemistry, physics, and biology. Correct? So in biology, botany and zoology is there. In physics also different types is there like optical physics. Okay, that is ray optics like that. So in chemistry also three branches are there. One is physical chemistry, another one is inorganic, next one is organic. Three branches are there. So physical chemistry means we are going to study how the reaction will take place, whether it releases the energy or it absorbs the energy like that. Okay. So if it is inorganic chemistry means we are going to study about the history of the elements. Means who discovered that element A, what is the atomic number of A, how it behaves, what is the charge. So history of that element is discussed in what? Inorganic chemistry. And the organic chemistry is only we are going to study about carbon and its compounds. If we want to study about carbon and its compounds, then it is organic chemistry. So today is I'm going to engage the one very important lesson for you people, that is classification of elements in the periodic table and the periodic tables. Because without knowing periodic table, you can't answer anything. Okay, because if you want to know hybridization, structure, reaction, oxidation state, for everything, you know NaCl is combined. Okay, one why so NaCl structure is this one, MgCl2 is there. Okay, why it is only combined with 1 mole of Cl? Why it is only combined with 2 molecules of or 2 atoms of Cl? That decided by what? The oxidation state of these two. That oxidation state explained by what? The classification of the periodic table. Okay, why it shows +1, why it shows +2, like that. Everything is comes under the periodic table. So without knowing that, we can't answer the chemistry. Okay, so that's why we are going to start with the first chapter, that is classification of elements and their periodic tables. Okay, so periodic trends means, so in the periodic table now we are using what? Modern periodic table, like SPDF blocks are there. So what are the properties? It is block, P block, B block and F block. That is all about what? Periodic trends. So we are going to study what happens to the periodic properties of the elements in the periodic table, and also how on what basis they are classified as SPD and F block. Okay, everything we are going to study in this. So in this, students, the first thing is how much marks this one is carries. Okay, so this carries 4 marks in the annual examination, 1 mark 1 question, and 3 marks 1 question. Okay, it carries 4 marks. Among that, 1 mark 1 question is there, 3 marks 1 question is there, and this is very easy chapter. Okay, this is not that much of only theoretical concept, but you have to understand on the along the period, along the group, what happens. If you know that thing, you can easily answer the questions. Okay, so now students, first one is how the modern periodic table frames. So in this, what are the objectives we are going to study? First one is genesis of modern modern periodic table. Next, second one, classification of elements in different blocks. Okay. Next, periodic properties of elements. The last one is physical and chemical properties. Physical and chemical properties. So listen, here I got periodic properties, here I got physical and chemical properties. What is periodic property means? That explain only in the periodic table. Physical properties means it is a boiling point, melting point, everything. So it can be the elements which is not present in the periodic table also we can say melting point and boiling point to them. Okay. So chemical properties means that how they react with different chemicals. Okay. So these properties different, these two are different. So that's why only these four topics we are going to study in this chapter. Understand? So among the 1 marks question is from the classification of elements or from the genesis of the modern periodic table. Like what is modern periodic law, what is Mendeleev's law, what is law of triads, what is law of octaves, that type of questions. Okay. And next here classification of element. What is the general formula of S block, P block, D block, and F block? Okay. Next periodic properties. This is important for 3 months. Among these, they'll ask question for 3 months. Among these two, they'll ask question for 1 month or from here. From these 3 topics, they'll ask question for 1 month. 3 marks question is from only this topic. Periodic properties of elements. Understand? Okay, let's discuss one by one. So students, as I told you, genesis of modern periodic table means how today's modern periodic table is formed, synthesized or prepared. Okay, so many theories are there that explains the classification of elements or arrangement of elements. So initially, listen, in the era 1800, okay, 1800, only 31 elements are there. Okay, so at the year 1800, only 31 elements are there. So at the year 1865, about 63 elements known, exactly more than double. Correct? So 31, 63 means it is a double of the initial elements. Okay, so at 1800, only 31 elements are discovered. Here at 1865, 63 elements were discovered. So later in the 1918, nearly 114 elements are discovered. Now in the today, in the modern periodic table, we are studying 118 elements. Correct? The modern periodic table total 118 elements are there. Still so many elements are there, but we don't know. So the last period of the periodic table is not yet completed. That is called as incomplete period. Why? Because we don't know only 118 elements are there. More than 118 may be present, 119 may be present, 20 may be present, 21, 22, 23. But they are not yet discovered. That means today's present the known elements is only 118. We don't know how many unknown elements are there. Right? So listen, at 1800 only 31 elements are discovered. But how many elements still there? 118. So it is not like only 31 elements are there. They are still not yet discovered. Okay? Now also 118 elements are there. That means they are discovered. And so many undiscovered elements are there still. Understand? That means that the periodic table is not yet completed. Understand? So this is how the periodic table elements goes on. So students, if any element is there, okay. So you know that if element is there, it has an atomic number Z and atomic mass E. That you know. Okay. So if I compare hydrogen means it is written as H11. That means atomic number is 1, atomic mass is 1. So if you write He24, That means atomic number is 2, atomic mass is 4. Okay, why I taken this? So this modern periodic table is classified on the basis of what? Atomic number, correct? So in the period here first hydrogen is there, here helium is there. Here 1, here 2, again 3 lithium, 4, 5, 6, 7, 8. Right? So in the increasing order of the atomic number, now the periodic table is arranged. Okay? So on what basis they arrange, they consider the element should be arranged in the base of atomic number. So listen, here atomic number is there, mass is there, proton is there, neutron is there, electron is there. Even though all these present in the atom, but they consider only atomic number, not atomic mass. First they consider atomic mass, but that is not that much accurate. Okay, so that leads to the modern periodic table. I'll explain the different class which tells about the classification of elements. Okay. Students, listen, 4 laws are there that explains the classification of elements. Okay, in that first one is law of triads. Law of triads. Second one is law of octaves. Third, Mendeleev periodic law. And last one is modern periodic law. Now what we are using is the modern periodic law. Okay? So these are the 4 different laws leads to the framing of the periodic table. Understand? So then we will discuss one by one. Law of triads. So this is explained by the scientist Döbereiner. In the year 1800 to 1829. Okay, this law is explained by Döbereiner in the year 1800 and 1829. So at this time, only 31 elements are known. Right? At this era, 1800, only 31 elements are known. Okay, so first I will give a set of triads. Tri means how much? Tri means 3. Correct? So mono means 1, di means 2, tri means 3. So law of triads means if frame a set of 3 elements. Understand? He explained a set of 3 elements. So first element I say here lithium, sodium, potassium. Okay. Next calcium, strontium, and next chlorine, bromine, iodine. These are the 3 sets he explained. So students, first consider the atomic masses of these. So the atomic mass of lithium is 3, atomic mass of potassium is 39. Okay, atomic mass of lithium is 3, atomic mass of potassium is 39. So later I will write sodium. Okay, so here atomic mass of just atomic mass of calcium is 40, and this one is 137. That is what? Atomic So your atomic mass of this chlorine is 35.5. This one is 1.7. Understand? Okay. So in between I write here sodium as the atomic mass 23. This one has the atomic mass 80. This one has the atomic mass 80. Okay. Later I wrote the middle elements. Initially I wrote first and third. Okay. So what is this law? So this one is 88. What is this law of triad says? Okay. This is a three set of triads. How many sets are there? How many elements are there? Three means 9 elements. At this time, how many elements now means 31 elements. Understand? At this time, 31 elements are known. In that, he explained only 9 set of elements. Means 3 set of 3 elements, total 9 elements. Okay. So listen, what is this law of triads? So this is one set means. Okay. So here the increase in the this Döbereiner tried to arrange the elements in the increasing order of their atomic mass. Understand? He tried to arrange the elements in the increasing order of atomic mass. He is considering what? Atomic mass, not atomic number. So why atomic number is not yet considered here means, so in this year, the electrons are not yet discovered. Protons and neutrons are discovered. Understand? The atomic mass means it is sum of protons and neutrons. Understand? That's why still they are not going to consider the electrons here. Okay? So electrons not yet discovered means they used to consider only atomic mass because they don't know electrons are there. Understand? So here, for the first concept is he tried to arrange the elements in the increasing order of what? Atomic mass. Understand? So here, listen. This is the first element. Atomic number is 3. Atomic mass is 3. It is third element in the set. That is atomic mass is 39. If you take the average of these two, 3 plus 39 divided by 2, that is 42 divided by 2, that is approximately how much? 21. Correct? So that is nearly equal to what? Nearly, approximately equal to 23. Understand? In this way. So here also you take. Here 40 plus 137 divided by 2. 40 plus 137 means 177 divided by 2. So this is 2 8s are 16, 2 8s are 16.5. Correct? So this is approximately equal to what? This one. Here you consider 35.5 plus 127 divided by 2. That is how much? One 77.5. Sorry. 162 by 2. No, 162 by 2, right? So it is approximately 81.25. That is nearly equal to what? This one. Approximately, not exactly, I'm telling, approximately. Okay. So students, by this what you are going to consider is, or what you are going to get, in the set of triads, the atomic mass of the middle element is the average atomic mass of the first and last element. Understand? The atomic mass of the middle element is the average mass of the first and third element. That is the statement of law of triads. Okay? What is the statement? The atomic mass of the middle element in triads is the average atomic mass of first and last element. This is the statement of law of triads. Understand? What is the statement? The law of triads is explained by the and proposed by the scientist Döbereiner in the year 1800 and 1820. Okay. So here what is the statement? The atomic mass of the middle element in triads is the average atomic mass of the first and the last element. This is the example. This is first set, this is second set, this is third set. The last example also. Okay. So students, as I told you, at this age, at this time era, only 31 elements are known. In that, he successfully explained only set of 3 elements, that is 9 elements. So 31 minus 9 means nearly 22 elements left. Understand? This theory fails to explain the set of triads for remaining 22 elements. Okay? If any law is there, that should be applied to each and every element, right? But it successfully explained this law of triads among only 9 elements. Okay? He fails to explain why the remaining elements are not showing this law of triads. Remaining 22 elements are there, right? Why those 22 elements are not ready to show this type of triads? He fails to explain that. That's why this theory is refused, means discarded. This theory is not considered. Actually, this is the first theory. Understand? This is the first theory. He tried to arrange elements in a manner, regular manner. But he fails to arrange all the 31 elements. And he fails to explain why. Understand? So this is law of triads and very important for 2 marks. 2 marks means in 3 marks question they may ask 2 plus 1 also. But if they ask only statement, that is 1 mark only. These statements are very, very important. Okay? So listen, the second law is law of octaves. Okay? So this theory is proposed by Newlands, scientist Alexander Newlands. Okay? In the year 1862, in the year 1862. Okay? So students here, this law of octaves. Okay, triads means set of 3 elements as I told. Oct means 8 elements. Oct means 8. The set of 8 elements is explained by this Newland. That's why this is called as law of octaves. Understand? So first I write the set of elements. So listen, start from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So listen, 1, 2, 3, 4, 5, 6, 7. Okay, next 8. So this is This starts from atomic number. Atomic number, atomic mass, I say. Okay, this much is enough, I said later. So students here, this is the set of elements or the example for the octaves. Okay. So you know the musical words that is sari ga ma pa. Again after pa, the next term is sa. Again it continues like sari ga ma pa like that. So with respect to sa, the next sa is a 8th word. So here we will write sari ga ma pa ni. So 1, 2, 3, 4, 5, 6, 7. The next term is sa. Again you consider this with respect to this next term is re. So every 8th term resembles the first term. If this is the first term, consider from here 1, 2, 3, 4, 5, 6, 7, 8. The 8th term and the first term is same. So re, if you consider this one as a first term, 1, 2, 3, 4, 5, 6, 7, 8. This is the, so first and the 8th term is always same. So this arrangement is also like a musical note arrangement. Understand? So that's why this is called as the octaves. Because set of 8 elements. Here you consider. So from here 1, 2, 3, 4, 5, 6, 7, 8. If you consider this one as element 1, this is the 8th element which comes exactly below the first element. Next, if you consider this one as first element, so 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th element. So this is, these three are in the same column, they behaves in the same manner. These three are similar. So if you consider this one as the first element, okay, 1, 2, 3, 4, 5, 6, 7, 8. So 8th element exactly comes below the first element. That tells about what? The first and 8th element are always same with their physical and chemical properties. Or the 8th element resembles the first element. Resembles means as it is. Okay, in the same manner. Understand? So what is the statement here? The statement is in the set of 8 elements, every eighth element resembles the first element. Every 8th element resembles the first element. This is the statement of law of octaves. Understand? So every 8th element means this. This is example. This is the set of 8 elements. So total how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Only 16 elements are there. Okay? In this law successfully explained only for these elements. Understand? The thing is, here, what are the postulates means? This Newlands is also try to arrange the elements in the increasing order of atomic mass. Okay? He also arranged the elements in the increasing order of atomic. I'll write the points here. He tried to arrange the elements in increasing order of atomic mass. Next, we try to arrange in a set of 8 elements. Okay, this is the postulate. So when he used to arrange the elements in the increasing order of their atomic mass with same properties, he got this much. Understand? So he studied different physical and chemical properties. These three show same, these three show same, these two show same. So after calcium students in the periodic table, the next element is scandium. After calcium in the periodic table nowadays, The next element is scandium, that is with atomic number 21. Okay, so this scandium is a D block element. Here this boron, aluminium all are P block element. There is no same chemical properties between D and P block. Understand? So these are P block elements nowadays, these are S block elements, these are D block elements. The next element after this calcium is scandium, that is entirely different from the properties of these elements. So that's why after calcium, it fails to explain how the law of octaves for the remaining elements. So listen, in this law as we know, 63 elements are known. In the year 1862, nearly the 63 elements are known. Initially I explained, correct? So initially 31, later 63, later 114, now 118. So at this era, 63 elements are known. Among those 63, he successfully explained this law of octaves for only 16 elements. Okay, so this law of triads fails to explain or fails to explain this theory for remaining elements. Understand? 63 is there, here 16 is there, nearly 40 plus elements are fails to explain this theory. Understand? And this Newlands fails to explain why these elements cannot able to show law of octaves. Okay? He successfully explained only this. Okay? He cannot able to explain or he cannot give a proper reason for not showing this theory about the elements. Understand? Remaining 40 plus elements are there. They are not ready to explain this law of octaves. That's why this theory is also discarded when the Mendeleev gives a perfect theory. Understand? So Mendeleev also give a perfect theory that is called as Mendeleev's periodic law. When Mendeleev discovered that law, at that time this law is discarded because this is only perfect up to this element, but he gave a successful reason for all the classification of the elements with the physical and chemical properties. So that's why this law is discarded. Understand? So first one, law of triads. It explains only 9, that's why it is discarded because it explains 16. So 16 elements are greater than 9. No? So law of triads discarded, this octaves is considered. When Mendeleev discovered this periodic law or periodic table, at that time he successfully explained more than 114, nearly 114 elements. Okay, he successfully explains. So that's why this one is discarded. So because this is the correct theory seems. Understand? So this is the second theory of genesis of periodic table. And the next one is model periodic table. So not model, Mendeleev's table. So students, how this Mendeleev's periodic table is formed means, so listen, this Mendeleev also, the scientists, try to arrange the elements based on their physical and chemical properties. So first what he did, he considered a table like this. Okay, here start from 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, like this. So 1, 2, 3, 4, 5, 6, 7. Okay, so first you frame a table with 7 series, 7 horizontal rows and 9 vertical columns with the number 0 to 8. Understand? So what he did first, he considered so many elements. So he tried to check their physical properties like boiling point, melting point, everything. And he tried to arrange them sorry, check the chemical properties also. For hydrogen, sorry. Okay. Hydrogen reacts with water means it forms oxygen means it forms H2O. Okay. If lithium reacts with water means it forms LiO. If sodium reacts with this oxygen means it forms Na2. Correct? So to balance this, I may take here 2. This is understand? So this is all about what? These are the first group elements. Hydrogen, below hydrogen, lithium is there, below lithium, sodium is there, below sodium, potassium is there. So all are given what? H2O, LiO, Na2. Same type of oxides. Means their chemical properties also same. Understand? So it used to consider this type of properties, like same physical and chemical properties. So it try to arrange the elements they are showing the same properties. Keep on arranging in the same group. If they form this type of compounds, we try to first hydrogen we discovered. Later we studied lithium. So lithium also form this type of compound means it places lithium here. Again, you consider sodium. Sodium also forms same type of compound means you place sodium here. If we consider magnesium, but magnesium reacts with what? Forms a compound like MgO. So it is not this type of compound. So you place magnesium here. Understand? So based on the properties, we try to arrange the table or elements, not based on the atomic mass. So when we arrange the elements according to the chemical properties, then they are arranged in the increasing order of atomic mass. Initially considered what? The physical and chemical properties. When you try to arrange the elements based on chemical properties, later they are arranged according to the increase in atomic mass. Means once you frame ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಎಲಿಮೆಂಟ್ಸ್ ಅರೇಂಜ್ ಮಾಡ್ತಾರಲ್ವಾ ಸೊ ಅರೇಂಜ್ ಮಾಡಿದ್ಮೇಲೆ ನೀವು ಈ ತರ ಬರ್ಕೊಂಡು ಹೋಗ್ತಾರೆ ಲಿಥಿಯಂ ಬೆರಿಲಿಯಂ ಬೋರಾನ್ ಕಾರ್ಬನ್ ನೈಟ್ರೋಜನ್ ಆಕ್ಸಿಜನ್ ಫ್ಲೋರಿನ್ is there here some iron oxides like that heavy elements are. Understand? So here atomic mass of lithium is 4, this one is 6, this one is 7. Okay, this one is 7, this boron is 5, 10 approximately, this is 12, this one is 14, this one is 16, and this one is 19. This is the atomic mass. Understand? Atomic mass I am writing, not number. Li36, this is I am writing, atomic mass. Understand? So when we try to arrange the elements in this manner, again they are arranged in the increasing order of their atomic masses. Understand? So then what is said after this? Is there another? And there is periodic flow. Okay. So students here, listen. The periodic properties. So listen, the chemical properties is the periodic property. So that is what, when we arrange the elements in the periodic property, consider they are arranged in the increasing order of atomic mass. That shows what? The periodic properties of elements are the properties of the element is the periodic function of their atomic masses. This is the Statement of the Mendeleev's periodic law. So what it states, the properties of the elements in the periodic functions of their atomic mass. Because when we study the properties, then they are arranged in the increasing order of their atomic masses. Understand? So from that, he concluded the properties of the periodic functions of the atomic masses. This is the Mendeleev's periodic law, and this is the table. So in about this, what are these horizontal rows called as, what is this vertical columns are called as, how they are classified, why this theory is discarded, that I will explain in the next class. Okay? Today we are discussed about law of triads, law of octaves, and Mendeleev's periodic law. Their statement is very, very important. Understand? 3 marks. What is law of triad? What is law of octave? What is Mendeleev's periodic law? Understand? To be thorough with that, then tomorrow's class we will discuss about the detailed study of the Mendeleev's periodic table. Okay? Thank you.